that's given, our reference angle, go across, and that side is going to be labeled as our opposite side. The side that is across the 90-degree will be our hypotenuse. And finally, the last side that's remaining is going to be adjacent. And I recommend using 3 letters to label the sides. That's it. So, next question. Primary trig ratios. There are 3 primary trig ratios: sine, cosine, tan, or sine, cosine, and tangent. Each can be expressed as a ratio of 2 sides of a right triangle. I'll show you what I mean by ratio of 2 sides. So, what does that mean? We got primary trig ratios here. We got the same triangle. So this triangle, these 2 triangles are exactly the same. Oh wait, no, sorry, I apologize. They're different. The difference, if you can see, it's a bit hard to see, is the reference angle. Which corner the reference angle is in. So this is where students make a lot of mistakes. They look at this triangle and they're like, oh, the bottom side is opposite. And then they forever always say the bottom side is opposite. That's wrong. It depends on the triangle. So for this triangle on the left, it says opposite. For this triangle on the right, it says adjacent. So never memorize ever which side you think is the opposite side based on the shape and the orientation of the triangle. Always, always, always use the angle that's given, the reference angle. So the reference angle is theta. That's the symbol with a little bit of an oval shape with a line. That's called theta. So theta is here. And if you go opposite theta, that's the opposite side. And remember, hypotenuse is opposite the 90 degrees. And then the adjacent side is the last one remaining. In this case, theta is the bottom left corner. So opposite is going to be this side here in green. And then adjacent is this one, and hypotenuse is that one. What do we do? What do we mean by ratios? Easy. Sine theta is equal to opposite over hypotenuse. That means when we are given numbers for our triangles, when we know how long and wide our triangles are, then we can put in the numbers in this kind of like fraction. A ratio is like a fraction, essentially. And you need to remember the formulas. So sine is equal to opposite over hypotenuse. Cosine, or cos, is equal to adjacent over hypotenuse. And tan, or tangent, is equal to opposite over adjacent. So a cool mnemonic device is to say SOHCAHTOA. So as an S-O-H, ka, C-A-H, and then toa, T-O-A. That's an easy way to remember because sine S, opposite over hypotenuse. Cosine is C, adjacent over hypotenuse. Tan is equal to opposite over adjacent. Now I'm gonna do this for one example for you, so you understand exactly what I mean. So our angle is here. That's very important. The very first thing you need to do is to label your triangle. So 5 is my opposite side. 13 is my hypotenuse. And then the last one is obviously adjacent. So what does that mean? I know that sine of angle theta is equal to opposite over hypotenuse. But we know the opposite is 5. And we know the hypotenuse is 13. So the final answer is sine theta is equal to 5 over 13. This is what you need to be able to do. Step 1 is to be able to do this. Obviously, step 1 is like labeling a triangle and then getting the formula, plugging in the numbers, but you know what I mean. Hopefully you know what I mean. All right, so cos theta, if we go back to the formula, it's adjacent over hypotenuse. And we know adjacent in this case is 12, and hypotenuse is 13. So cos theta is equal to 12 over 13. And finally, tan theta is equal to opposite over adjacent, which is 5 over 12. Tan theta. Over 12. That's it. That's all you have to do. You have to be able to write the three formulas, the three primary trig ratios, with their fractions correctly. Now we're going to learn how to use these formulas, the three formulas, to solve for certain things. Just a reminder, this is all a review from grade 10. So hopefully some of you will remember this. If not, and grade 10, or perhaps grade 10 was a really long time ago, it's okay. This is what I'm here for. So let's do this. So question is asking, which trig ratio or trigonometric ratio should you use to solve the triangle below? It's a multiple choice question, but I'm going to do every single one of them just to show you what that would look like. First thing always that you do is you label your triangle. So this is the opposite, and this is hypotenuse, and this is obviously adjacent then. In this specific example, they did not give us the value for my adjacent side. We don't know how wide this triangle is, or whatever this length that you want to call it. We don't know it. But we do know opposite and hypotenuse. So that means only one of these formulas for these trig ratios will work. What do I mean by that? Let's start with tan. We know tan theta is equal to opposite over adjacent. We know opposite is 14. And we know adjacent was blank. We don't know it. So we can just write question mark or A. Just leave it A, I guess. All right, so 14 over 8. What about cosine? We know cos theta is equal to adjacent over hypotenuse. Once again, we don't know what A is, but we know hypotenuse is 24. And then the last one is sine. And we know sine theta is opposite over hypotenuse. And in this example, we have 14 over 24. Hopefully you can see that only one of these ratios is complete. See, in this case, A, we don't have A. We cannot solve this because we don't have a complete fraction. But for sine theta, 14 over 24, we know that's a fraction. We know we can work with that. So the answer is going to be sine theta is equal to 14 over 24. And we have to use the sine formula. We cannot use the tan formula or the cosine formula because it's not complete. So that's what the question was asking. Which trig ratio should you use? You should use the sine trig ratio. So now this is your turn. I'll make a poll. So go ahead and do your best. So these are your results. So 2 of you said sine, 4 of you said cos, 2 of you said tan. So pretty diverse. Let's see what the answer is. Well, first we have to probably do all three just to we have to label our triangle. So we know that our angle is 54 degrees. How do I know that? Well, it's the only thing that's inside the triangle. that's between two line segments, aside from this one. This is obviously 90. So this is opposite. And then opposite the 90 degree is going to be my hypotenuse. That would mean that my x is adjacent. And what we really want is we really want the adjacent side and the hypotenuse side. We do not want opposite because we don't know what opposite is. It's completely blank, and we're not really looking for it. We're looking for x in this case. So let's do that. So sine is going to be opposite over hypotenuse, which is opposite over 12. And we can't solve that because we don't know what O is. And we're not looking for O. Cos theta is going to be adjacent over hypotenuse, which in this case, adjacent is x, and hypotenuse is 12. So this has both things that we want. We want the x and we want the 12, so the answer should be cos. And if I were to do tan, just so you can see, tan is going to be opposite over adjacent, which is opposite over x. So each one of these fractions has one of the things that we want. This fraction has the 12, this fraction has the x, but it's not complete. Only cosine formula has both the x and the 12. So the answer is cosine. Hopefully you can see that. Okay, let's continue. Solving for sides. So we're going to label the triangle always. Determine the correct ratio to use. So that's what we just did. We have to figure out, are we going to use sine cos or tan, which formula? And then we're going to give substitute information, meaning plug in the numbers, and then actually solve for it. So how do we solve for x in this case? So in this example, what we need to do is always label your triangle. So you find your reference angle, which is the only angle inside the triangle. That's opposite. Then you do the opposite of the 90 degrees. So that's obviously hypotenuse. This is adjacent. We have to find x. How to figure out x? Well, we know that for this triangle, we are given the opposite and hypotenuse, or we're looking for opposite and we're given the hypotenuse. So adjacent has nothing to do with our formula. So if I were to do sine angle theta, but wait, this is important. Our angle is not theta anymore. What's our angle? Anyone in the chat? What's our angle? Just type it in. What number is it? Perfect. At least one person knows. It's 40. Our angle is 40. That's important. It's because we have to plug in that information. So sine 40 is equal to opposite over hypotenuse. Sine 40 is equal to, opposite is going to be my x value. Hypotenuse is 20. So this is our formula that we're going to use. Question is, how do we use this formula? This is important. Whenever it comes to trig ratios and you're trying to solve for anything, always make two fractions on both sides of the equal sign. And if you don't know how to make a fraction of something that isn't a fraction, all you do is make that fraction line and make it over 1. That's it. That's it. Just a sidebar. Let's say if I have a number like 57 and I wanted to write that as a fraction, 57 over 1 is the answer. If I had a number, let's say 103, and want to write that as a fraction, guess what? Make it over 1. So if you have any whole numbers and you're confused how to make them into fractions,